So today I'm going to present my PhD done at INRIA, Rennes, IRISA, and INSA, entitled Towards Avatar-Based Interaction in Virtual Reality. And this PhD was supervised by Anatole Écuyer, Ferran Argelaguet, and Ludovic Oyer. So the studies of this PhD take place in virtual reality. So virtual reality is an alternative world where so an alternative world where everything is simulated. So to show a virtual world to users, we can put them a head-mounted display, so a headset that we put on their head that completely hides the real environment. In this virtual world, they cannot see their real body anymore, so we can give them a fake body called an avatar. So with this body, so in the virtual world, they can interact with this body, but the virtual world can be really different from the real environment. So we don't really know how users will perceive this new body. For example, if it's really different from their real body, like here it's a kind of a robotic body. And also the real world can be different, like here it's in zero gravity, so we don't really know how people will perceive and interact with this new body. But it's really important to know this because avatars can be really useful in many applications. First, we think about social VR applications, where users can meet with other people in a virtual environment and socialize. But avatars could also be useful in other types of applications, such as sport training, phobia treatment, or rehabilitation, where it's more efficient when you can see your body. So an avatar, so this virtual body, it's the digital representation of a human user that facilitates interaction with other users, entities, or the environment. So at the beginning of virtual reality, it was mostly simple representations, such as spherical cursors or floating hands. But now we can have more complex avatars. And in this PhD, we focus on body parts and full bodies. And because users cannot see their real body anymore, they can feel a sense of embodiment towards this new body. So it means that the virtual body's properties are processed as if they were the properties of the biological body. So actually, the virtual body kind of replaces the biological body for the users. With this body, people can interact with the virtual environment. There are lots of interaction possible in VR. So first, people can select objects, so choose an object they want to interact with. Then they can manipulate this object, so translate it, rotate it, or change its scale, for example. Also, users can navigate in the virtual environment. So they can go forward and turn around. And finally, there is also system input. So it's all the input that can be passed to an application. So for example, text input, but also choosing an option in a menu. So we have the user and we have the virtual environment on the other side with the avatar, which is the counterpart of the user. So users can perform some actions using input devices, and thanks to an interaction technique, they will have a control over the virtual environment. Then the virtual environment can give feedback to the user thanks to output devices. So it's the headset, but also, for example, touch feedback. And the user will perceive this feedback and can do other actions after. There is also this special relationship between the user and the avatar, this sense of embodiment, which will be the core of this PhD. So the goal of this PhD is to better understand the interrelations between all these entities, so between the user, the avatar, and the interaction. So as I said, the core aspect is this sense of embodiment, so this illusion that this new body is a user's real body. It's a really complex process, and it was defined by Kiteni et al. As a mix of three subcomponents. So first, the sense of body ownership, so feeling like the body is our own, the sense of agency, feeling in control of the virtual body, and sense of self-location, so feeling located inside the virtual body. Embodiment is really complex to measure. It's something really personal, and we cannot read in brains for the moment, so we use subjective questionnaires to measure embodiment. So we have lots of questions, and we use Likert scales, so people can answer questions from 1 strongly disagree to 7 strongly agree. There are 3 questionnaires that are often used and that will be used in this PhD. But the problem with subjective questionnaires is that they are subjective, so they depend on users' interpretation of the questions. So it's good to also use objective measures. So one measure that is often used is the reaction to a threat. Because if you have a virtual threat, for example, a circular saw like here, if you think that the virtual body is your real body, then you will tend to react to the threat. And one way to measure reaction is to use, for example, a skin conductance response. So you can put sensors on the skin and know when people have an emotional reaction to an event. Also, depending on the experiment, there are other measures possible. For example, here in a study where users were embodied in a child body, they measured voice frequency because when people were embodied in a child avatar, they tended to speak with a higher pitched voice. Now, so I'm going to present some related works on all these entities by focusing first on the user. And on this slide, I'm going to talk about personality because it's something that differentiates a user. It's something that we will explore in this PhD. So the user and his personality can have an influence on the sense of embodiment. So personality and embodiment were first studied in the physical world with the famous rubber hand illusion. So it's an experiment where we put a rubber hand in front of the participant and we hide his real hand. And then we stroke with a brush both the rubber hand and the real hand synchronously. So progressively, the participant thinks that this rubber hand is his real hand. And the strength of this illusion was found positively correlated with empathy and negatively correlated with body awareness. So people who are too aware of their real hand tend to accept less this rubber hand. Also, there are some studies on personality with the sense of presence. So it's different than the sense of embodiment. It's another sense that is commonly studied in VR. It's the sense of being there in the real environment, like if we were in a real environment. And this sense was found positively correlated with agreeableness, extraversion, or anxiety. But to our knowledge, there is only one study on embodiment and personality in VR. It's the work by Genet et al., which investigated locus of control and found that internal locus of control, so it's people who think they are in control of their lives, tended to feel more in control of their avatar. They had a higher sense of agency. Now we're going to focus more on the interaction technique, which can also impact embodiment. So an interaction technique, it's made of an input, also a control law, and some feedback that is given to the user. So there are some studies, for example, on the influence of input modality. So when we use hand tracking, people have a higher sense of ownership than when using controllers to track the hands during interaction. Also, it's possible to use different input devices for hand control and interaction to still have some hand tracking to track the hands, but also have efficient manipulation, for example, when interacting with a tablet. Also, there are some studies on the impact of the input on user expectations in terms of control of the avatar. But most of these studies focus on hands and manipulation, but not really on full body motions. So for example, if there are no studies on locomotion, which uses the full body to interact. So we will see this aspect later. So for the control, there are some techniques that modify users' motions. So for example, they can amplify users' motions, like here to be able to reach remote objects. So there are some studies on the impact of distorted motions because they can influence, negatively impact the sense of agency and self-location. There are some studies on how to decrease this impact of distorted motions. So distortion can be introduced progressively. Also, it has less impact when it actually helps users to perform a task. And finally, so for the feedback, there are lots of studies on the influence of perspective. So people have a higher sense of ownership and also self-location when they see the avatar from a first-person perspective. But for example, the sense of agency is less impacted when interacting from a third-person perspective. There are also some studies on the feedback when grasping objects. Also some studies on the effect of body visibility and transparency, because when we interact in VR, to avoid occlusions, because we don't have always the touch feedback, so it's complicated to interact with a hand that hides objects. So we can make the hand a bit transparent, and it was found that we can maintain embodiment towards a transparent body as long as it's not too transparent. Also, there are some studies on the influence of haptic, so touch and force feedback, which is beneficial to the sense of embodiment. Now let's focus on the avatar, because avatars can also impact the way users interact. Avatars can impact object perception. So for example, if you hold a cube with an enlarged, so bigger hand, and with a realistic texture, you will perceive this cube as being smaller as it actually is. Also, avatars can improve distance perception, and for example, also the perception of capabilities. So if you have a body that serves as a spatial reference, then you can know if you can step off a ledge or not. Also, avatars can impact detection of motion distortion. So it was found that when you have an offset between your real hand and a virtual hand, you detect less this offset when you're represented by a realistic hand than when you're represented by a spherical cursor. Also, when we distort avatars' motions, so users will tend to adapt their own motions to what they see, so to the avatar's movements. Avatars were also found to impact performance. So there are some studies on cognitive tasks. So for example, people tend to solve a puzzle more quickly when they are represented by a full-body avatar. There are also studies on motor tasks. So for example, here, participants had to pick small cubes, and there was no difference between the conditions with or without virtual hands. And finally, there are also some studies on Proteus effects, so it's how the avatar appearance can actually impact our behavior and how we perform depending on this appearance. So the related work shows several interactions between all these entities. So we will, in this PhD, we will focus on 3 research axes. So first, the influence of users' characteristics on the sense of embodiment. Then the influence of the interaction technique on the sense of embodiment. And finally, the third research axis is the influence of the avatar on the way users interact. In this PhD, we have 4 contributions. So the first one is on the influence of the user's personality on the sense of embodiment. Then we have a contribution on the interrelations between interaction and avatar embodiment, focusing on locomotion techniques. Then we have another study also focusing on this interrelation between interaction and avatar embodiment, but this time focusing on anisomorphic manipulation, so techniques that distort users' motions. And finally, in the 4th contribution, we will give practical guidelines towards what we call avatar-friendly manipulation techniques, so techniques that are compatible with avatars and take the avatar into account during the design. So now let's first focus on the first contribution on the influence of the user's personality on the sense of embodiment. So the motivation of this study is to better understand individual differences in embodiment scores, because there are lots of studies on embodiment, and there are some people who give really different scores, so people giving high scores and others giving really low embodiment scores, even in the best conditions. So we don't really know why we have these variations in embodiment scores. Also personality, so it's something that differentiates users, and it was already studied with the sense of presence and with the rubber hand illusion. So in this study, we had one research question, so does personality influence the sense of embodiment? So to understand this, we used a simple motor task, because first we need to elicit embodiment. So we need a way to make users embody the avatar. So we use a motor task, and then at the end of the experiment, there was some embodiment and personality questionnaires. So this work was done in collaboration with Rebecca Fribourg, Daniel Mestre, and May Slater. So this is the task that people had to perform. So there were some trajectories shown on the screen. So people had to reproduce these trajectories. And they could see their avatar from a first-person perspective and also indirectly in a mirror. So in this experiment, we had 123 participants. At the end of the experiment, a virtual character would enter the scene and stab the virtual hand. So the goal is to see whether people react to this threat, so if they felt embodied in the avatar. So at the end of the experiment, we had several personality questionnaires. So we chose personality questionnaires that measure different types of traits, which were studied before and with validated questionnaires. So first we had the Big Five inventory. So it's a questionnaire that measures 5 personality traits: openness, conscientiousness, extraversion, agreeableness, and neuroticism. We had also a questionnaire on the locus of control. So to see if it's internal, so for people who think they are in control of their lives, or external, if people think that other people or chance have an influence of the events in their lives. And finally, we had a body awareness questionnaire. So as dependent variables, we had embodiment and the response, the reaction to the threat. So for embodiment, we used the questionnaire by Gonzalez, Franco, and Peck. And for the reaction to the threat, we actually measured the movement done by the users using controllers that they were holding in their hands to see if they actually reacted to the stab. For the analysis, we used a principal component analysis. So it's an analysis to have different components per categories of question. So we had several components, so 4 components for ownership, 1 for agency, 1 for perception of threats, and 1 for external appearance. So this kind of analysis was already used in other studies. And then with the scores that we computed per component, we computed the correlations with personality and body awareness. So globally, so the results. So for the Big Five traits and body awareness, so we did not find lots of correlations, but we found one that is interesting between neuroticism and perception of threat. So neuroticism, it's a bit like anxiety. So people tend to be nervous, reacted more to the threat at the end of the experiment. But for the locus of control, so we found several correlations. So we found a positive correlation between internal locus and agency, which is in line with previous work by Genet et al. But for ownership, so we had several principal components for ownership, and we found correlations with external locuses of control. So it seems that ownership is more influenced by an external locus. So people think they are not in control of their lives. So it's different from the results for agency. So in conclusion, so the goal of the study was to better understand individual differences and to see if personality could influence the sense of embodiment. So globally, we found that Big Five traits and body awareness were not a good lead to explore to understand individual differences. So maybe these questionnaires are not sensitive enough to measure variations, but locus of control is definitely a good lead to explore to understand individual differences in terms of embodiment. So now we're going to move to the second contribution. So this contribution explores interrelation between interaction and avatar embodiment, and we focus on locomotion techniques, so techniques used to navigate in the virtual environment. But there are lots of locomotion techniques that exist, so we can classify them into several categories. So we have, for example, room scale-based techniques, so it's actually real walking. Motion-based techniques, when you need to do a movement to go forward, so for example, walking in place. You also have controller-based techniques, so for example, steering techniques, where you use controllers to go forward, for example, by clicking on a button. And the orientation can depend on For example, here for head steering, it depends on the head orientation. Also, you have teleportation-based techniques. So, for example, when you point a location where you want to go, and then you're teleported to this location. So in this technique, for room scale-based techniques, motion-based techniques, and control-based techniques, they are continuous. So the movement when you're going forward is continuous, contrary to teleportation, where you instantaneously go to the location you chose. Also, these techniques have different levels of interaction fidelity, so different levels of resemblance to rewalking. So rewalking is like we move in the real environment. Walking in place is a bit like walking, but on the spot. But steering is really different from walking, so it has a low level of interaction fidelity. But all these techniques have been studied and invented without a user representation. But depending on the way users are represented in virtual reality, it actually impacts the visual information that is available, and it could also impact the sense of embodiment. So for example, you see it's very different if you are represented by only 3D controllers or if you have a full body avatar. So the motivation of this contribution is to better understand these interrelations between avatars and locomotion, because lots of locomotion techniques have been invented but without using an avatar, and also locomotion uses full body motion, so it could possibly influence embodiment. So we had 2 research questions. Does the locomotion technique influence the sense of embodiment? And does embodying an avatar impact the way users navigate and also their preference in terms of navigation depending on the technique? So in this study, we had 2 factors. So first, we had the between subject factor, the technique. So each participant used only one locomotion technique between rear walking, walking in place, and head steering. So we had 20 participants per technique, so 60 participants in total. We also had the within subject factor, the appearance. So each participant did the experiment twice, once without an avatar, and just seeing 3D controllers, and once with a full body avatar. In this experiment, we had 4 tasks. First, we had a training task. So people had to pick mushrooms on the ground, and it was to get used to the locomotion technique and to the environment. Then we had 3 main tasks. So each task was chosen to actually focus on one body part to ensure that people could see their virtual body. So the first main task was the corridor task. People had to walk back and forth in the corridor with mirrors at both ends. So they could see the whole body in the mirror. Then we had the path following task. So people had to follow a cross moving on an H-shaped trajectory. And in this task, so the focus was on the legs because people could see their legs in their field of view. And as a performance measure, we used the mean distance to the line to see if people could correctly follow the trajectory. Finally, we had the columns task. So it was like the training task. So people had to pick mushrooms, but this time we added columns in the environment to see if people would collide with these columns or avoid them. So we measured the collisions between users' shoulders and the columns, and in this task, so people could mostly see their arms. So for this experiment, so we use an 8 meter by 8 meter environment. So the real environment would match the virtual environment. And also, so users had a headset and controllers to control their hands, but they also had Vive trackers on the feet to animate the legs, and also trackers on shoulders to measure the collisions. So for the data, so we use an embodiment questionnaire again, this time with questions only on ownership, agency, and self-location. We also had questions on the ease of tasks and the preference between the 2 appearance conditions. For the analysis, we use the mixed two-way ANOVA and Kruskal-Wallis tests. So globally for the results, so we found similar levels of embodiment with all techniques. So here it's an example of a question on ownership. So if people felt like the virtual body was their own body, and we can see that the medians are quite similar for all conditions, and the results are averagely very high. And so it means that potentially there is a low impact of the level of interaction fidelity on embodiment. So it's actually possible to embody an avatar even with a low fidelity technique like steering. So even if you just click on a button to go forward, you can embody your avatar. We did not find significant difference on the number of collisions between the two conditions with or without an avatar. But this is surprising and contradictory to other studies. This may be due to the task and to the distance between the columns. So maybe people didn't need to look at the avatar to avoid the columns. Also, in terms of preference, there was a slight preference for the condition with an avatar. So because here we can see that the scores are above 4, so people preferred having a full-body avatar, but the results were more contrasted for the steering condition, with people highly preferring having a full-body avatar and other people highly preferring the no avatar condition. So in conclusion, so the goal of this study was to understand interrelations between locomotion techniques and avatar embodiment. So we found similar levels of embodiment with all techniques, which means that we can embody an avatar even when using low fidelity locomotion technique. Also, so we found that participants preferred having a virtual body during locomotion, except with the steering condition where it was more polarized. So now I'm going to present the third contribution. So this time we focus on manipulation, and more specifically on anisomorphic manipulation. So it's techniques that distort users' motions. So there are lots of anisomorphic manipulation techniques, so techniques that distort users' motions. So we can amplify motion, for example, to reach remote objects, or we can also decrease users' motions. The problem with these techniques is that they introduce an offset between the virtual hand and the real hand. And sometimes this offset can be really big, like here. If you have an extended arm, it also creates strange feedback. So it can impact the sense of embodiment, especially sense of agency, because you can feel like you're losing control of the avatar, and also a sense of self-location, because you don't feel located with your avatar anymore. So there are some studies on how to minimize the impact of such an offset. So there is these studies that are presented in the related work, which try to make the distortion and the offset less noticeable. They found that when you use a realistic hand as user representation, the offset between the virtual hand and the real hand, shown here as a ghost hand, is so less noticeable than when you're represented only with a spherical cursor. So we can try to make this offset not noticeable, or on the contrary, maybe we could actually show the offset and also show real motions done by the user. So as soon as the user actually moves, he has a feedback of his movements. So we can add an additional representation of real motions. There are already studies investigating multiple body representations. So for example, here it's in augmented reality, but it's the same, like we have already one body and we add an additional body, a ghost body. So we have this dual body representation. So we wanted to investigate such feedback for anisomorphic manipulation. So the motivation was to decrease this impact of distorted motions on embodiment. And also there was no study investigating the effect of also seeing real motions during anisomorphic manipulation. So we had two questions. So do dual representations influence the sense of embodiment during manipulation? And do dual representations impact performance? So in this study, we had two within-subject experiments investigating two types of distortions. So first, in the first experiment, we used amplified motions. we use the go-go technique. So it's a technique that amplifies users' motions to reach remote objects. In this experiment, the task was to pick apples in a tree, then look at them, and sort them depending on whether they were flawless or rotten. So in this experiment, we had 24 participants. And in a second experiment, we used decreased motions using the prism technique. So this technique slows down the user's motions depending on their hand speed. So if you move normally, then there is no distortion, but if you start moving slowly, then the hand is moving even slower, and this can help to gain precision when manipulating objects. So in this experiment, the task was to place correctly objects on a target. So the object was this cylinder with an antenna, and the target was the same object, but transparent and red. So in this experiment, we also had 24 participants. So in this experiment, there were different possible appearances to show distorted and real motions. So motions could be represented by a realistic body, a ghost body, or nothing. So here, let's see an example. So it's for amplified motions, so with the go-go technique. So we have this realistic arm. This is the arm that is going to be used to interact with the virtual world. So it's a realistic arm, so R. And then we have an additional ghost, G, arm that is here to give feedback of real motions. So this realistic arm, we call it the interactive representation, because it's the arm used for interaction, which will show distorted motions. And this ghost arm is the collocated representation, because it's collocated with the real user's arm. So in the two experiments, we had several conditions. So first, we had this ordinal condition. So it's an appearance that is already used in some VR applications or studies, where we have only one single representation, a realistic arm, and the movements of this arm are distorted. But we can add a feedback of real motions using a ghost arm, so it's the RG condition. Then we can have the opposite condition. So when we interact with a ghost arm, and real motions are shown with a realistic arm. And finally, we had the fourth condition in the second experiment, where we showed only real motions. So we couldn't use this type of condition with the go-go technique, because you need to know where is your virtual hand. But when you use the prism technique, you can show only real motions, and only the motions of the object are slowed down. So here it's a video of the RG condition in the first experiment. So it's a dual body representation, where the interactive representation is a realistic arm, and we can see the feedback of real motions with the ghost arm. We have the opposite condition, where we can interact with an extended ghost arm, and we have a realistic arm to show real motions. So here it's the same, so the GR condition in the second experiment. So we can see that people can interact with the ghost arm, and the realistic arm continues to move because it shows real motions. So the motions are not slowed down. And here we have the null R condition. So we show only real motions. So we can see that the object is slowed, but the arm continues to move and then interpenetrates the object. So as data, so we had embodiment questionnaires again. So this time we used a different version of the questionnaire by Peck and Gonzalez-Franco, measuring embodiment with questions classified into 4 components. So ownership, appearance, multisensory, and response. We added another questionnaire by Ross and Latoskik, measuring questions for 3 components: ownership, agency, and change. So these questions were asked for the global representation, but we also chose 3 questions from this second questionnaire. So 1 question on ownership and 2 on agency, that we ask specifically for both the interactive and the collocated representation. see if there are differences in terms of embodiment between the two representations. Also, we asked participants to rank conditions in order of preference, and as objective measures to measure the performance, we counted the time to pick 20 apples in the first experiment, and in the second one, we counted the number of objects correctly placed in 3 minutes. Now, so I'm going to present the results. For the preference, so in the first experiment, there was a slight preference for the Arnold condition, with 10 people ranking it as their preferred condition. So here, so the colors indicate the rank. So the red, dark orange color is for when people ranked this condition as their preferred condition. And the votes were more split between the two draw body representations. But in the second experiment, the preference for the Arnold condition was clearer, with 13 people ranking it as their preferred condition. Then we have the RG condition, and finally the GR condition was the least preferred. So in terms of embodiment, so for the first experiment, we found that people had a higher agency when an arm was used as interactive representation than collocated representation. So for example, for the ghost arm, so people had a higher sense of control when they were using the ghost arm to pick the apples than when it was used to show their exact real motions. So it's really interesting because it shows the importance of interacting with the virtual environment to feel a sense of agency. In the second experiment, we had different results because in this experiment, we found higher ownership and agency scores towards the realistic arm than towards the ghost arm. So maybe because people in this experiment, people could always see the draw body representation or the two representations next to each other, so they could compare them, and they always preferred the realistic arm, or the realistic appearance. Also, when we looked at the global embodiment scores, so we found similar scores in all conditions. So it means that it's also possible to embody a draw body representation. But with the task that we used, we couldn't find an impact of the representation on performance. So in conclusion, so the goal of this study was to explore a new type of feedback during anisomorphic manipulation, so manipulation with distorted motions. So we found that it's possible to embody a draw body representation, but that people prefer having a single representation. And also, so we couldn't find an impact of draw representations on performance, so neither a positive or negative impact. So now I'm going to present the fourth contribution, in which we gave practical guidelines towards avatar-friendly manipulation techniques, so techniques that are compatible with avatars. So the goal of these techniques is to ensure a sense of embodiment, which is something usually not taken into account. So the motivation is that we need such guidelines to take the avatar into account during design process. Because for the moment, when designers create new techniques, they take into account usability or performance, but not the sense of embodiment towards the avatar. So we need to understand how the manipulation techniques can influence the sense of embodiment. So to understand this, we did an analysis of the state of the art. So because there are some studies on manipulation and avatars, so we analyzed these works to propose a set of 14 guidelines, so classified into input, control, and feedback. And we also propose some research topics for the future to understand more all these interactions between avatars and manipulation. So here are the guidelines that we proposed. So I'm going to focus just on some of them. So for example, for the input, so it's better to use hand tracking for the sense of embodiment, because I said in the related work that it's better for the sense of ownership. For control, when you use distorted motions, it's better to introduce this distortion progressively. And for the feedback, as we did in the contribution with the draw body representation, it's better to have body continuity So for example, when you use the go-go technique, it's better to have an extended arm than a floating hand going away, because it helps to preserve embodiment. So now I'm going to sum up the contributions of this PhD. So in the first contribution, we investigated the influence of personality on embodiment. So we couldn't find direct correlations between Big Five traits, body awareness, and embodiment. But the locus of control really seems a good lead to explore, to understand individual differences in terms of embodiment. In the second contribution, we focused on locomotion techniques, and we found that it's possible to embody an avatar with all the techniques that we studied. So it seems that the interaction fidelity does not have an impact on embodiment for locomotion. And also participants preferred having a virtual body during locomotion, but it was more contrasted for steering. In the third contribution, we focused on manipulation with distorted motions, and we found that it was possible to elicit a sense of embodiment towards dual representations, but that people preferred having a single representation. Finally, in the fourth contribution, we proposed guidelines to help developers develop new techniques that are more compatible with avatars and that can ensure a good sense of embodiment. Now I'm going to present some perspectives for the future. So for the first contribution on personality, so it would be interesting to investigate further this locus of control, which really seems to be linked to embodiment. We could also investigate other personality traits, such as empathy or absorption, which were found correlated with the rubber hand illusion or the sense of presence. Also, we could use machine learning maybe to identify different types of users' profiles, and maybe ideally to be able to predict level of embodiment before using a VR experiment. And also in the future, we could also have VR experiences adapted to each user. So we could customize VR experience. So instead of having one VR experience, we could have like multiple VR experiences customized for each user. For the second contribution on locomotion, so some participants reported being disturbed by such motion artifacts. Here you can see that the knee bends a bit strangely. So it was disturbing for some participants, so we need to better understand the impact of such motion artifacts on the sense of embodiment. Also, we could compare different tracking methods, because in our study we used inverse kinematics, but we could use full body motion tracking. And also, we could try comparing such tracking to animations, like walking animations, and also study feedback for other types of locomotion techniques, such as teleportation. So in the third contribution on dry body representations, some users reported to have difficulty to rank the conditions in order of preference because they actually didn't really pay attention to their user representation. So it would be interesting to study the impact of user attention during embodiment studies, so to see where they're actually paying attention if they're actually looking at their avatar. So to do this, we could use eye tracking. And also in this study, we used two types of anisomorphic techniques, but we could investigate other distortions such as collision handling. And also we could display the second representation only in some cases. For example, if the offset is too big between the virtual hand and the real hand, then we show it so the user can feel in control again. Also, so we use the dry body representation, but there are other studies on embodiment of such multiple bodies. So for example, for up to 4 avatars, or here embodiment of multiple hands to decrease target selection. So it would be interesting to define such multiple embodiments. And there are also some studies on multiple users sharing one avatar. So it would be interesting in the future to use more such multiple embodiment, which could increase collaboration, empathy, maybe in collaborative applications. Finally, we propose guidelines towards avatar-friendly manipulation techniques, but we could extend these guidelines to other types of interaction. So for example, for locomotion, Also, for system input, there are lots of VR applications using such body-based interfaces, which are naturally avatar-friendly because they use the avatar as special reference. So it would be interesting to develop such techniques. So this PhD led to four publications, so 3 in international conferences and 1 conditionally accepted to IEEE VR journal track. Well, thank you for your attention, and now I'm ready to answer your questions.